In this section, we will look at the development tools for the MK Ultrawideband Shield and Ultrawideband Tag SR040 and how to set them up. The MK Ultrawideband SDK provides all the tools required to start developing ultrawideband use cases. The MK Ultrawideband library allows you to focus on the development of the application logic instead of the low-level details of ultrawideband. It supports the NXP QN9090 MCU and Nordic NRF 52840 MCUs and can be easily ported to other platforms. The MK Ultrawideband Toolbox Android application allows you to use your phone to run the examples provided in the MK Ultrawideband SDK and visualize ultrawideband ranging and angle of arrival data. The MK Ultrawideband PC Shell application allows you to use a Windows PC to run the examples provided in the SDK and read ultrawideband ranging and angle of arrival data as well. Moving on to the ultrawideband library, it is a precompiled library that simplifies the development of ultrawideband use cases for Trimension SR040 and Trimension SR150 ICs. It exposes intuitive APIs to initialize and deinitialize ultrawideband hardware, configure ultrawideband ranging session parameters, detect other ultrawideband devices over Bluetooth Low Energy and start ultrawideband sessions with those devices, receive real-time distance and AOA notifications, and filter devices based on a whitelist or a blacklist policy. The MK Ultrawideband Library Lite is provided to enable the evaluation of the use cases and functionalities. To access the complete version of the library, a license agreement with MK is required. But there is more than the library, the mobile app, and the MK PC Shell. You might feel a bit overwhelmed about where to start with all of the options and resources included in the kit. That's why there is extensive documentation with comprehensive instructions and quick start guides. There is a full set of documents to help you getting started with the ultrawideband technology using the MK Ultrawideband Kit hardware and software content. Documentation provides step-by-step instructions to run ready-to-go demo applications and use the development platform and software libraries to create your own ultrawideband applications. The list of included documentation is extensive. It includes the MK Ultrawideband Kit SR150 SR040 Quick Start Guide, the tracker and distance alert user manuals, the MK Ultrawideband SDK Guide, the MK Ultrawideband Shield 2 User Guide, the MK Tag SR040 User Guide, the MK Ultrawideband SDK Porting Guidelines, the Amutech SR150 and SR040 modules datasheets, MK Ultrawideband Tag SR040 and MK Ultrawideband Antenna Board hardware design files, and angle of arrival evaluation using the MK Ultrawideband Kit. Now let's see how to set everything up step by step. The MK Ultrawideband SDK and the included demo project make it easy for you to get acquainted with the toolchain and flatten the learning curve. The application layer contains example applications using the SDK and they are delivered with the kit. The MK Ultrawideband library is responsible for managing the ultrawideband and BLE functionality, manage configurations, etc. It may be extended in the future with high-value functionality like sensor fusion and TDOA. The NXP Ultrawideband API is the SR040 and SR150 middleware as delivered by NXP. It includes functions to interface with NXP Trimension chips. The platform port is the platform-specific code used by the SDK to access BLE functionality, power modes, and other components, such as LEDs. We'll see these in more detail in the following session, but for now, let's look at the library integration example with the PC Shell. Your MK Ultrawideband Kit has everything you need to get started easily, as we've seen before when running the included test cases on your smartphone. However, if you want to flash custom software or adapt the provided MK Ultrawideband library examples to the MK Ultrawideband Shield and tags, you will also need a programming board. we strongly recommend using the LPC Link 2 from NXP, as it has been tried and tested, and in fact the full MK Ultra-Wideband SDK has been developed using this piece of hardware. If you prefer to follow written instructions, you can read the detailed hardware requirements and setup in detail in the MK Ultra-Wideband Shield user guide document. So let's see about the software aspect now. To get up and running with the development on the MK Ultra-Wideband Kit hardware using the MK Ultra-Wideband SDK, you only need a few software components. Let's see what you need to have the whole toolchain set up and ready to go. You'll first need the MCU Expresso from NXP to compile, flash, and adapt the MK Ultra-Wideband library to your needs. This is an easy-to-use IDE. You'll also need Python 3.9 to run and modify the MK PC Shell software. A bundled installation with PyCharm is highly recommended as well. Optionally, you can also install Android Studio for compiling the MK Ultra-Wideband Toolkit app from source or adapting the app to your needs. The toolchain has been validated to work on Windows, but it should be also compatible on macOS and Linux as well. Same as before, the detailed installation process is explained in the MK Ultra-Wideband Shield user guide. For your convenience, we will show a summarized installation process next. In this video, we'll be showing how to install and configure the toolchain for using the MK Ultra-Wideband SDK. First, let's install Python. Navigate to python.org and download the installer for your operating system. Launch the installer and check the box to add Python 3.9 to the path variable. Click on Install Now and the process should take a couple minutes. Next we'll be downloading MCU Expresso. Navigate to mcuexpresso.nxp.com, click on the tab Software and Tools and click on Learn More about MCU Expresso. Click on the download link and sign in with your email address or NXP company ID. Click on MCU Expresso IDE and agree the terms and conditions after reading them. Finally, click on the installer for your operating system. To install MCU Expresso, simply launch the installer, accept the agreement after reading it, and simply go through the setup screens clicking next. The default options are OK. The installation process will take a couple of minutes and the process is sped up here. When finishing the installation process, it may prompt you to install drivers to Windows. If that's the case, just click on Yes. Next, launch MCU Expresso and you're ready to go. The next step is to import the MK Ultra-Wideband SDK. First, extract the zip file in a folder of your convenience, and then go to MCU Expresso, click on File, Import, General, Existing Projects into the workspace, and browse for the unzipped folder. Default options are fine and just click on Finish. Before we can compile, we need to also import the QN1990 SDK. For that, locate the zip file in the resource folder and simply drag and drop it to the installed SDK window on MCU Expresso. To build the project, simply select it on the left, click on the drop-down menu on the hammer icon and select the device you're building for. In terms of hardware, you need your MK Ultra-Wideband kit and an NXP LPC Link 2 board, as well as a 10-pin debugging cable. You'll also need a micro USB and mini USB cables. Make sure the jumper 2 is bridged and jumper 1 is open. First, install the antenna board on the MK Ultra-Wideband Shield 2. Then attach the 10-pin debugging cable to the LPC Link 2 as shown here, and the other end to the debugging port on the MK Ultra-Wideband Shield 2. Then attach the micro USB cable to the MK Ultra-Wideband Shield 2 and the mini USB to the LPC Link 2 programming board. Finally, connect both USB cables to your computer and you're ready to go. Finally, to flash the device, click on the MCU icon, make sure that the connect script is selected, should be automatically, choose program master race first, make sure the file to program is selected, and click on run. Choose the LPC Link board and click OK. If you want to start a debug session, click on the blue bug icon on the toolbar, search for link server again in case the LPC link doesn't show up and click OK. The debug session should now start.